All right, so we are going to look at solutions, and you should remember a solution as a homogeneous mixture of two or more substances. The solvent is the substance that is present in the greater quantity, and the solute is the substance that is present in the lesser quantity. So if you want an easy way to remember which, a solute is a smaller word, so it's the smaller part. When you have an ionic compound dissolve in water, the particles of the ions actually dissociate and come apart into individual ions, and you end up with each ion being surrounded by water molecules. The orientation of the water molecules is significant. The oxygen side of the water molecule will face the positive ions, and the hydrogen side of the water molecules will face the negative ions. So this is called dissociation. And it's also important to point out that some of these solutions are what we call electrolytic, because the substance that dissolves, forms ions when dissolved in water, and therefore can conduct electricity, whereas a non-electrolyte is a compound that does dissolve. It's still attracted to water molecules, but it does not form charged particles, so you do not have the ability to conduct electricity. Just to give you an idea, you have all ionic compounds dissolving to form electrolytes, and you also have all strong acids dissolving to form electrolytes as well. And weak electrolytes would be those weak acids or weak bases which only partially dissociate, only a few molecules or a portion of the molecules break apart. Any other compounds, molecular compounds that dissolve in water, are considered to be non-electrolytic. So, again, just to remind you what that means, an electrolyte will conduct electricity when dissolved in water. Weak electrolyte will only dissociate partially, so there still will be some conductivity, but for example, in this diagram, you see the bulb is only dimly lit. Just to be able to identify those strong acids, which is very important. So you should have this committed to memory, at least, what those strong acids are. Strong bases as well. And then there are some solubility rules that allow you to predict which ionic compounds will dissolve in water. And those are important to be familiar with as well. Being able to predict solubility will also help you to identify what we call precipitation reaction. So when you mix the ionic compounds, when sometimes those combinations form compounds that are insoluble, and that is referred to as a precipitate. So these, what we call double displacement reactions or exchange reactions, are very common in chemistry. You may recall that you would swap the positive and negative ions, so the cation from one compound will now be associated with the anion of the other compound. And then if one of the compounds formed is insoluble or a gas or water, then a chemical reaction has occurred. The other thing we should point out is to just make sure that you understand exactly what the physical states are and what's actually undergoing a change. So that's actually emphasized when you're representing the chemical reaction. So we want to talk about the fact that there are different ways of representing a chemical reaction. One is referred to as a molecular equation, where you show the full formulas for the reactants and their products, but this is sometimes less useful than what we refer to as a net ionic equation. So let's look at how that works. So in the ionic equation, you would show the actual ions as they are dissociated in the solution. And then you would actually go about eliminating those ions who has not changed their physical state from the left and the right. So they've undergone no change, and then what's left is showing the change that occurred, and that is what we refer to as a net ionic equation. Okay? All those species that were removed are referred to as spectator ions, right? They're present in the solution and in the vessel, but they're not undergoing any change. So let's just review that again. To write the net ionic equation, you first start with your balanced molecular equation, then dissociate everything that dissociates completely, all your strong electrolytes, your soluble ionic compounds, your strong acids, your strong bases, etc., and then cross out any species that remains unchanged in physical state from the left and the right side. What remains is your net ionic equation. Let's just review acids and bases very quickly before we move into the next part, which is really important. We have a definition according to Arrhenius, because there are a couple different contexts for discussing acids and bases. We're going to be talking about the Arrhenius definition as a substance that produces hydrogen ions when dissolved in water. There is another definition by Bronston and Lowry which focuses on them as being proton donators, because if you think of hydrogen ion as being an atom of hydrogen which does not have an electron, all that's left is your proton. There are 7 strong acids, as we mentioned earlier. These should be committed to memory so that you know what those are. And the Arrhenius base is a substance that increases the hydroxide ion concentration when dissolved in water. And those can also be viewed as by Bronston and Lowry as proton acceptors. So the strong bases are all the soluble metal salts that contain hydroxide ions. So what happens in an acid-base reaction? In an acid-base reaction, the acid donates a hydrogen ion and the base accepts a hydrogen ion. So you need to be comfortable viewing any acid-base reaction in terms of the proton or hydrogen ion, etc. So in general, when a solution of acid and base are combined, you have 2 products, which is what we refer to as a salt and water. When a strong acid reacts with a strong base, you get a net ionic equation. It's always the same. It's just going to show the hydrogen ions combining with hydroxide ions to form water. So we have a unit that we use, a combined unit that we use to represent the concentration of a solution called molarity. So we have 2 solutions that can contain the same compounds but be very different because of the amounts of the compounds that they contain. So molarity is a way that we measure the concentration of that solution. It's defined as the moles of solute over the volume of the solution in liters. Okay, so that's the total volume of the solution, which is the combination of the solute and the solvent. So this is quite important to understand. When you want to create a solution of known molarity, you would actually weigh out the exact mass of the solute, and add it to what we call a volumetric flask. Volumetric flask is a specific piece of equipment that is used for this purpose because it's got a single marking in the neck of the flask here that that is going to correspond to the final total volume of the solution that is desired. And so once you add the solute, you can just dissolve in a small amount of water and then continue adding water and mixing until you get to that line. You can also start with a more concentrated solution and deliver a specific volume of the more concentrated solution to a new volumetric flask and then dilute that volume to the final desired volume so that you can have lower molarity. The molarity of the new solution can be determined by using M1V1 equals M2V2, okay, or here they're representing C as the more concentrated and D as the more dilute, so MCVC equals MDVD, okay. So again, if you recall, we have this moles as our central unit, which we use along with the coefficients from our balanced equation. And now we have yet another relationship to moles, which is going to be your molarity. So now we can use molarity in our stoichiometric calculations. Titration is a very important analytical technique where we can calculate the concentration of an unknown solution by reacting that solution with another solution of known concentration. At the end, we need to have some way of knowing the endpoint, and that is called indicator. We have many different indicators that we can use in chemistry, so we'll talk about those, but you will be doing this quite a bit, so I hope this helps.